In this video, we're going to compute the inverse matrix of a 2x2 matrix. So the matrix I've chosen to invert here is the matrix 1, 2, 4, 3. And if you remember from the course slides, computing the inverse matrix of a 2x2 matrix is a fairly straightforward process. The first thing we need to do is compute the determinant of A. That's for two reasons. If we find that the determinant of the matrix we're trying to invert has a determinant that's equal to 0, well, we can stop right there. You can't find the inverse of that matrix. And if it's not 0, well, then we're going to need the determinant to calculate the inverse of this matrix. So let's just go ahead and calculate the determinant of the matrix. So determinant of A is the determinant of 1, 2, 4, 3. So that is the product of the main diagonal, subtract the product of the off diagonal, so 3 minus 8, or negative 5. Now, since the determinant is non-zero, we can find the inverse of this matrix. So to compute the inverse of this matrix, we're going to take the reciprocal of the determinant, so in this case, negative 1/5, and multiply that by the matrix obtained by taking the main diagonal elements of A and swapping them. So we'll have a 3 and a 1, like so. And then taking the off diagonal elements, the 2 and the 4, and changing their sign. So negative 2 and negative 4. So there's our inverse matrix. Now, I'm going to verify that I haven't made any calculation errors by multiplying these two matrices. So if in fact this A inverse that I found is the inverse of A, and I haven't made any errors, when I multiply the two together, I should get the identity. So I'm going to do one of the verifications, at least one direction, right here with you. So I'm going to take A inverse and multiply that with A. So if I've done things correctly, when I take this product, I should get the identity matrix. So negative 1/5 times 3, 4, it's negative 4, negative 2, 1, times the matrix A, which is 1, 2, 4, 3. Okay. So at this point, maybe some of you see why I chose to leave that scalar negative 1/5 out in front of the matrix. Because when I'm doing these matrix products, I don't want to have to do a bunch of calculations with fractions. So I just leave it out in front, and I'll multiply through by the negative 1/5 last. So I have negative 1/5, and to get the first entry here in the matrix product, so this is going to be 3 times 1, or 3. And I'm going to add to that negative 2 times 4, or negative 8. So 3 minus negative 8 is negative 5. And things are looking really good. So if I were to take negative 1/5 and multiply by negative 5, I'm going to get positive 1, which is exactly what I want in the 1, 1 position of the identity matrix. To calculate the 1, 2 entry, I'm going to take 3 times 2 and add to that negative 2 times 3. So I get 0. Which is exactly what I want. To get the 2, 1 entry, I take negative 4 and multiply by 1, and I add to that 1 times 4. So negative 4 plus 4 is 0. And finally, to get the 2, 2 entry, I'm going to take negative 4, multiply by 2, give me negative 8, and add to that 1 times 3, or positive 3. So negative 8 plus 3 is negative 5. Now, last thing I'm going to do is multiply through by that scalar out in front. So negative 1/5 times negative 5 is positive 1. Negative 1/5 times 0 is 0. Negative 1/5 times 0, again, 0. And negative 1/5 times negative 5 is positive 1, which is exactly what I want.